Now that's another thing we did in about 2 weeks. We don't load that up because we shouldn't say that. It's only done in 2 weeks. Now we're coming to a little bit more challenging stuff. Images. I mean, if we're talking about semantic in order of text and numbers, they are some kind of self-describing. You know, if you have characters and you know the language you're looking for, then all of a sudden you can judge, you know, that's a word, that's the meaning of that, and so on and so on. But if it comes to pixels, I mean, pixel is a relatively dumb element. You have X and Y, and you have maybe 186 of color, and that's it. Maybe if it's in the neighborhood of another same type of color, you can say it's an even area. You know, it's only one color there. There's no gradation or something. But then it's about done. Much more you don't get out on a pixel. But if it comes to forensic and if it comes to pattern matching, I mean, look those two pictures. I mean, those are the same, but for a technical system, they don't really look the same. I mean, look these elements here and look that element here. I mean, for a parser, for a technical system, that's not really much the same. But if you look the whole, and if you think, okay, if that would be complete, then it would be very close to that, and so on, then we as a human will say, yeah, that could be the same. So in detail, it looks like that. That's how the picture's coming in. And that's how the digital retina we have designed will encode that. Because, you know, obviously it tries to make shapes and corners and, you know, the edge and so on. And what I'm showing here is that our system is able to generalize patterns and find out the rules behind the patterns. So it's actually not a pattern recognition we are doing. We are generalizing how the pattern is built and then applying the rules onto the data. So having unknown information, we can find pattern. We haven't even known that we are looking for that pattern. So we don't need to have a reference in order to start looking for patterns. You can even say, if it's totally even and no pattern at all, this is correct. That's how, like SMH, the famous watch manufacturing, are looking on surfaces. You know, they say, if we do an image here, you just see nothing. It's all golden. No scratch, no nothing. If you would have a rule-based system to check it out, you would have to learn the system all types of scratches. But you don't know them because every time they're a little bit different. But if you can tell the system the rules which are leading to a scratch, then the system can tell you whether there is a scratch on or not, because it doesn't look at the scratch itself, it looks at the concept. And that's exactly what we're seeing here, that this system understands that this kind of a form can belong to this kind of concepts, and it generalizes the possibility how that concept can be built, and then it will find it in even a total noisy background. So that's if you're working from pixels. Now, if it comes to signatures, I mean, that's really a point where it gets tough, because signature, I mean, that's my signature, that's my barcode, you know. But the problem is sometimes I have about 5 or 4 lines more or less. I never count them. I just do like So I mean, I screw all those systems because they never can judge whether this is mine or not. But if you look at that, you will say, yeah, that looks the same concept, you know. So human would accept that, but not the system. And again, the system will not count how many lines are done. They will look for anomalies or specialities in the concept and then recognize this kind of the concept, and also it has the timeline. So it will see that over the time my signature is changing a little bit. It gets longer, it gets shorter, and then you have a longer period again and have a shorter period again. So it will understand the concept and the changes on the concepts. And then it's possible to match these kind of things. Now that's another tough one. Time correlated value chains. I mean, here we have a classical end-to-end situation. Because if you have every second a data spot, and you say, do we find the patterns? I mean, every data spot to every data spot is a pattern. Boxed, you know, reversed and in any directions. And now the second point is, now you see here stock the stock curve of 2007, the 20th of the 6 months, and you see some other numbers here, and you see all the other index, the other companies here. And what we can show and prove here is that without any pre-processing of those data, the system will tell us whether there are some anomalies in. That means dents which appear, which are different than all the others. They kind of, coming out the noise. And also it will tell us not only that certain kind of dents are very interesting, it also is able to judge every day what is noise and what is an anomaly. Because even those dents, even if they're looking the same, if you have that much of a dent, but the whole day goes up and down like that, it's not interesting, because now it's noise. But if the day goes like this and you have one coming up here, then it's interesting. So if you would show him the pattern, he would go wild, because he will tell you all here and here and here and here. But then as a profession, you will know and say, no, that's not, because the overall situation doesn't appear the way it should, in order that this is an interesting pattern. So it's again a question of the concept and not a question of the pattern. And again, the system can tell us not only that we say, hey, go on out and look whether this pattern is an interesting one, because I know that would be a nice one to trade. You go in here and you go out there. But then also I will ask, now if that's appearing, is there any preamble which then leads us to that? Because if you go for trading, you like to know before it happens that it will happen, because then you start trading. Now here we prove that the system evaluated this curve as interesting because it checked that the preamble in different companies under different circumstances with different amplitudes, it's not really the same, but the concept was the same, is leading in this time frame to that very interesting dent. And that will change in 2 months. That will be disappeared. It will be different next time. So that's another very hard time, and there are systems out there, they're doing that, but the problem is the time. You like to have this online, real time, and the other problem is usually you would have to pre-transform that. You have some Fourier transformation and others in order to find the anomalies at all, and you would have to give him samples before you start. Now here again it's the reversed. The system tells us what it found, and then we as an expert confirm it or say no, that's not interesting. And then of course it goes into medical. Again, I mean, many of those skin anomalies, they appear and looking very similar to other ones. There are only little differences between that one being a good one and that one being a bad one. So again, you need to understand the concept behind. You can find those relatively easy, because usually you have a kind of a very noisy and even background. So it's easy then to find the place where there is something different than the background. But then to judge whether this one now is a special one and it's a bad one or a good one, again, you need to know how, and you need to have biological inspired intelligence in order to tell what kind of a anomaly you found here. In medical, we are one step further. We have been appointed by a government-founded project in Switzerland, which is called SEMPER. And SEMPER is a project where we try to get information into a let's say, uniform semantical answering and dialogue system. So having information from different sources coming together, using different medical languages, like having doctors making their notes and everything. Well, this language, even in German, is different than having a user group talking about the same. So they're talking about high fever, and they are talking with the Latin names about the same. So it doesn't even match, even if it's German.